Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to show you the detailed drawing of the other components. Since I have already shown you the detailed drawing of the bottom casing, the top casing, and also the opening lid. Okay, the rest of the components, like if I show you in this exploded view drawing, we have the rest of the component is this steering rod, the plastic cap, the coupler, and also the bracket to hold the tactile switch and the push button itself, right? So it means I have another, if you look at flexible coupler, plastic cap, we have material in WM. Plastic cap is plastic, steering rod is metal. And number 4 is the push button. And number 5 is the tactile switch. It means I have another 5 more components to go. Alright, in this video, I would like to do, I try to do, if here is this is my opening lid, so I will add another sheet here. So here I will not rename it, later I will rename it, actually what is the appropriate name for this new drawing sheet. I try in this video to fit all those 5 components into one drawing sheet. We can do that in the set of working drawing. Right. Okay, here I've decided, alright, about the title block. I will edit it, and here the title, so that it can fit. Okay, if I click at this, maybe I can adjust to make it more on like this. I try to reduce the number of lines here. So, and hold on, the title I can put it up here. So I have 5 components: steering rod, plastic cap, flexible coupler, tactile switch bracket, and push button. Right, so the material I don't have to put here because we have a lot of parts here. Later in the drawing content, then I will put at the bottom of each drawing view, I will put the number of the component, the name and the material and the quantity at the bottom of each drawing view of the component, right? Okay, about the scale here. Okay, drawing number, later I will decide what will be the drawing number. About the scale here is supposed to be 1:1 scale. So it means that it is a full scale. And make sure that everything is completed here, and we have a third angle symbol projection. And now I will do the detailed drawing of these 5 components and I put it into these drawing sheets here. So the first one should be the steering rod. Alright, for the steering rod, okay, if you look under the view palette here, since we don't have the menu here, so since I have not yet opened the steering rod part modeling file, so I will click and browse. So I will select the steering rod. Okay, now we have the menu here. This is all the possible view that we can drag into this drawing. Alright, I've decided that for the steering rod, since the way my part modeling file is, the right view is actually the front view for this drawing. So I will drag only the right view here. Okay, then I will bring up to show the plan view. Alright, so I don't need the other isometric view, I don't need it. Alright, about this front view, I deleted. There's a reason why I deleted. I only want this top view of the steering rod. Okay, here the scale is 1:1. Okay, this is a full scale of the steering rod. For the steering rod, I don't need another, I just need this orientation. Actually, this is a top view, and I need a left view of this top view. Alright, that's enough for the steering rod. Okay, this steering rod, okay, this need to be tangent edge removed. Okay, if I go for, since this steering rod is a typical orthographic drawing, if I go for hidden, show the hidden line, if you look here, it's kind of like we have kind of a complex hidden line, since we have a coil spring wrapped around this helical shape of this steering rod. So sometimes it's okay if we put it show only visible only, or in terms of clarity. since this standing rod is just a simple object, we have a long rod and it twisted to make a helical, right? So there's nothing features behind that this long rod, all right? So I just off the hidden line in terms of, for the sake of clarity. All right, about here, I have to go under notation to make a center line. So I simply select this line and SolidWorks put a center line to show that it is a long rod. Okay, okay, let me save my file first. Okay, another thing is that if I select this object here and open part in position, SolidWorks will open my steering rod part modeling file. So I need to on the since I have this helical shape, I need to on that base circle that I have done to create this helical curve here, because I have a base circle of diameter 20 here. So I need to make it on. So it is on, and let me save my file. If I go back to the drawing mode, the idea of it is that I want to do this left view here, and it can show the base circle, then I can put the dimension for the base circle, which is diameter 20, right? Okay, to make this left view, okay, so I can go for, if I go for this view palette, sometimes I'm not sure which view that is can really related to this side view of this top view. Okay, another way to do this, if I select this viewport, and I right click, I go for drawing views and I go for auxiliary view, and it asks any edge that I can use to make this auxiliary view. So I just select this edge. If I go to this direction, as you can see, this is orientation, but I don't want to go to the right view, I want to go to the left view. So it is like this. And another thing is about the setting on the left, I don't want this arrow of this auxiliary view, and I just off it and I click OK. Okay, about the title here, I can delete it. All right. So I have this outline of the base circle. So later I will do dimension to put dimension diameter 20. Right. I also have on already the sketch of the arm. Right. Okay, now I will go for dimension for the steering rod. Okay, under annotation, we have smart dimension. I can go for this total length. The first thing is about total length up until the cross section of at the end of this helical shape. I have a circle here. If I click at this circle, so I go for bottom direction. Now I have the dimension total length is 110. So I go for no decimal point. Right. Another thing is about, since this is a wire, this is a rod with a diameter, and I go for this line. So is there a diameter 1.5? Right. So the rod diameter is 1.5, total length is 111. Another feature to show is, as you can see here, all right, if I click at the center mark here, I delete it, I do it manually, annotation, I put a center mark since I have this circle, which is already shown. Okay, by default, the SolidWorks use 2.54 millimeter. I uncheck use document default here on the left here. So I will go for 1, or if I go for 0.5, okay, this is 0.5. Okay, let me go for 1 to make it a little bit like this. So this one is a center mark for this left view. And okay, here I can put the diameter. Okay, I have a circle already on here. Okay, but sometimes if the circle is not shown here, just to mention to you, under the view here, height show, by default the sketch is on. If I off, so the circle, the base circle that I on, I show it visible in my part modeling will not be shown, since here under the view, height show, make sure that the sketch is on, right? So it means that the sketch from our part modeling for base circle for this helix is shown here. So now I can do dimension for the circle to give that diameter is 20. Okay. Okay, diameter is 20. And another dimension that I can show is about the angle of this arm. From this line to this line, I can put the angle like this, right? Alright, since this steering rod, actually the dimension is not complex. Okay, another features to show that since we have this helical shape here, I need to give kind like extra notes here to show what is the total number of revolution of these helical things here. So since if you look in the part modeling file, the helical that I've done is 1.35 revolution, right? 1.35 revolution. So it means in my drawing mode, so I need to show, hold on, I have to put a note here. I click at here and just capital letter N mean number of revolution. I can put it like this, 1.35, right? 1.35 revolution. The N means that is a number of revolution. Okay, okay, I believe that's all for the dimension of the steering rod. Right. Okay, about here at the bottom here, because here I have the steering rod. If you look in the exploded view, steering rod is component number 5, right? So here I have to put balloons like this. Okay, then I just click okay. About the text here, okay, if I click at those balloon and about the balloon text, I put it 5, right? I put it 5 and we have a balloon 5 here. So then here 5, okay, we have the number of this component is 5 based from the bill of material. And here I would put the name is steering rod. Steering rod. Then the next line will be the material is in my bill of material is metal. I think I should change it to steel. And the quantity is 1. Right? So here we have the kind like extra note for this. So we have to do it like this because since we have more than one component in the same drawing paper, drawing sheet here, so it means that I have to put the number of the component based on BOM, the name, material, and the quantity. And also another thing that I forgot is about the scale. Since the scale I use is 1:1, so I don't have to put scale. But if this 10 rod I magnified it like 2:1, I have to put the scale here, right? If I didn't put the scale at the bottom of quantity 1, it means that it follow this drawing scale here. All right, the next component will be the plastic cap. If I go to view palette, okay, I have nothing here since I have not opened the plastic cap part modeling file. So I will browse, then I go for plastic cap. All right, I will drop the plastic cap at this upper right corner here. Okay, let me zoom it a little bit because it's kind of relatively so small. Okay, I will go for right view here. If I bring my right view to this drawing sheet here, okay, let me zoom it to make it bigger. So this will be the top view. Actually, the right view is front view for this drawing, and here is the left view like this, and another view will be isometric view. Right? Okay, I just press escape and okay, about since it's too small, and I select this main view and I will go for the scale of I have decided to go for 2:1 because I think 2:1 is big enough. Okay, for this isometric view. I got to make tangent edge remove. And if I go for shaded mode, it's kind of like it have an outline. So I will go for like this, or maybe you can go for this shaded mode. All right, about this view, okay, let me drag like this. Okay, since if you look here, let me adjust the position. Okay, so since this is a front view, this is a top view, and this is a left view. What I want to do is, I want to make this front view is a section view. It means that this left view have a cutting plate, and also this top view also a section view. So it means at this section view or front view, I have a cutting plane. All right, in order for me to do that, I need to, actually I need to delete both of these views, both of this front and the top view. Let me explain to you, because this is left view. Okay, this left view, I leave it like this. Okay, first thing is that tangent edge remove, and the left view is not a section view, so I must show the hidden line. Right. Okay, another thing about the center mark, I don't want to use, I just delete it. Okay, maybe I can uncheck use document, so I go for one. Okay, one is good enough about the scale of that center mark. And all right, I need to make this front view is a section view, so it means that on this left view, I will make a section. I go for vertical, and I go like this. Click OK, then this front view is a section view, right? Section view. Okay, let me click OK first. Okay, about the label, yeah. It's not supposed to be BE. I don't have any cutting section like X here, so it means that I can label this as X. Make sure it's capital. I simply click yes. So it's stated here section XX, right? Okay, here I put scale to 1 since I'm already magnified this plastic cap to 1 scale. Okay, let me delete first scale to 1 here, because I will put scale to 1 at the bottom node here, since like here steering rod I don't have scale after quantity 1, but for this plastic cap I will put after quantity, that I will put the scale to 1. Alright, so this is section XX. Okay, now I want to do the top view is also a full section view. Alright, okay, to do that, another section view, I'll go for horizontal and I snap at this middle point. Then click OK. Then I bring it up. So this top view is also a section view. Okay, I click OK, but let me click OK first. But if you look, the pointing of this section BF here is pointing upward. Since this is third angle projection, so I will select this cutting plane here. So I go for flip direction, it means the pointing downward. Okay, about the level is, since this is XX, so this is supposed to be YY, right? Okay, my mistake. This is supposed to be, logically, this is supposed to be XX. Okay, this is supposed to be XX, and this one is YY, right? It's kind of, I follow the axis horizontally XX, this is YY, but actually it's okay to put any label that you want. Okay, I have this section YY, this is section, okay, this is section YY, right? And the above is, okay, let me bring it up a little bit. Okay, above is section X. Okay, here I need to delete the scale. Later I will put the scale to 1 at the bottom node of this detail drawing of this plastic cap. Okay, let me save my file. All right. The next thing is about this. I need to put a center line here. Select this two line, and also about this hatching. Okay, same goes for here. Okay, now I will do dimension, right? All right. To do dimension, the first thing to do is about, okay, we have the cap here. So this left view will show this cap diameter. I will go for dimension of this diameter of this cap is 10. And also we have a cut through holes here. So I will go for this dimension. It goes for 2 millimeter. So I will drag it like this position about the leaders, and the value is no decimal point. Okay, I will drag like this. So this one's a cut through hole and about this diameter 10. Okay, so this is a diameter 10. Okay, another dimension I need to show, since I need to give a detailed dimension for this. Okay, why do I make this front section view and top section view? Because I need to show to you that this is not symmetrical, since I made the modeling of this plastic cap by doing intersection. Based on the output of the intersection, I have the internal volume to create this shape of this plastic cap. So it is not symmetrical, right? Okay, to prove it to you, if I give this dimension, I need to, from here, if I go dimension from this point to this point, I make a vertical dimension. So this is 9.02. If I go for the internal dimension from here to here, it is 6.95. Okay, if I go this dimension on the front view from this point to this point, so it is 8.4. As you can see, it's different. If it is symmetrical, the value of this outer diameter and inner diameter must be the same. Okay, for this inner diameter on this front section view is 6.36. It is not symmetrical. Okay, let me do some adjustment here. So here to do. All right, another dimension to put is about the level. Yes, since I have here, I have a cap, but the level from this up until here, it need to be shown. So I can put the dimension here from this line to this line. So it's 4. And another dimension is about the thickness. Since I have the thickness here, so it's there, it's put the thickness is 1. So everything is shifted to the right. So I need to do adjustment again. Okay, 1. Okay, like this. Okay, let me see my file again. And okay, I already put the thickness is 1, and also the length here is 4. Another dimension to put is about, okay, since I have a cap here, a dome shape, so I need to put the radius, so I can go for this top view here. So I need to put this radius. Okay, radius. So I have the radius there. Okay, another dimension is the total length of this plastic cap. The total length, I need to give dimension from this line up until this line. So I go above, and Okay, let me do some adjustments. So I need to to save space because since I want to put five component into one drawing, so it means that this space for this detailed drawing of this plastic cap have to be at the optimum space. Okay, I believe that's all the dimension for the. Let me make a final check. Yeah, I believe that's all the dimension for the plastic cap. Okay, one last thing is about uh, the local nodes here. So what I can do, okay, let me select this thing first. Okay, this I select this and I Control C to copy and Control V, paste it, and this one I can just bring it here. All right. Okay, about the number of this plastic cap, if I look at the BOM, plastic cap is component number 4. So I click at this balloon, it is 4, and it is plastic cap. The material is plastic, and the quantity is 1. Okay, now after the quantity is 1, since I need to make another line, then I will do for scale. Scale to 1. So it's stated here that this plastic cap is 2 times bigger, right? Because in the title block, the true scale is 1:1, but relative to true scale, so this plastic cap is magnified 2 times because scale is 2:1. Okay, let me do some adjustment here to put this detail drawing into the right position. Okay, now I put the position for this both of the steering rod detail drawing and the plastic cap detail drawing to the right position. Okay, now I will show you how I will do detail drawing of the other components. Okay, before I put the next component for the detail drawing, which is the flexible coupler, if you look here, the steering rod, the material is steel. Before I forgot, in the assembly drawing, steering rod, I need to change it to steel. Right, same goes for the BOM for the explorer view. Since I found out steel is actually the material for the steering rod is steel, because steel is safe enough to be used as a steering rod to steer the coffee with the milk, right? Okay, now I will show you how I will do the detail drawing of the flexible coupler. Alright, to do the detail drawing for the flexible coupler, here under the view palette, I will browse for the flexible coupler part modeling file. Okay, since flexible coupler is a simple hollow cylinder with a cutout with certain distance, and it's kind of small. I will go for right view. Simply I drag it here, and I will zoom it. It's kind of so small. So this is the right view. Right, I don't have to go for isometric view. Just press escape. Okay, about this main view, I have to magnify it for 1. Okay, I think for 1 is good. So this flexible coupler is just like a hollow cylinder, but actually we have a cutout by certain distance. Alright, I will do kind of section view. It's much better to do section view for this. I will delete this front view. And for this side view here, I will not use document default. If I go for if I go for 0.5, okay, in this case, since the size is so small, okay, I go for 1 for the size. I think it's good enough like this. So this will be the center mark of the side view, and I will go section view. Right? I go for vertical section view and at the center, then click OK. So this will be the front view, will be a section view. Okay, just click OK. Then, okay, about the label is I have already X, X, Y, Y. And this one I can go for, actually, we can go for any label, but this one I go for, maybe I go for J. Here I put level J, capital J. Alright, the scale for one later I will put in the at the bottom node. I just made it as like this section JJ like this. And about the hatching, right? Okay, now I will do dimension. For this, another thing is before dimension I need to put a center line. Okay. Okay, now I will do dimension. First is for this diameter, 2.5. Second is for the inner diameter, 1.5. The next one would be the length, 8. And the next one will be this length, 3. Right? And I think that's all for the dimension, so I need to do adjustment here. Yeah, I think that's all for the dimension for the flexible coupler, because since it is a simple component. Right, about the local node here. Maybe I can drag the isometric view to this position, and this isometric view will be for 1. Maybe I can go for 2 1. Okay. And about the display, I can go for shaded this. Okay, let me move this kind of position to the, make it to the right position. Okay, this is about the flexible coupler. Okay, now for this one, I will copy and I will paste it. Okay, for the flexible coupler, the component is number 3. Okay, so this will be 3. Material is plastic. Quantity is 1. And I need to enter and board the scale. This now I scale it to 4:1. Alright, 4:1. So this flexible coupler local node. Let me save my file. Okay, I've done the detail drawing for the flexible coupler. The next one will be, after the flexible coupler, will be the bracket to hold the tactile switch, and the last one will be the push button. Alright, the next component will be the tactile switch bracket. So under the view palette, so I need to browse the tactile switch bracket part modeling file. Alright, if you look under this view palette, so I will try for the front view. Let me try front view, only one view here. And I will go for the top view and also the isometric view. It's kind of like too small. Okay, let me press escape. Okay, for this tactile switch bracket, so I will go for the scale will be, if I go for 2:1, let me go for 2:1. If I go for 4:1, I think it's too big. Okay, let me go for 4:1. So this will be the isometric view. I go for 2:1. But for the front view and the top view, I remade it as 4:1. Alright, so for this tactile switch bracket, I don't go for the left view or right view because it's kind of like the left view or right view is not significant to show the profile shape of this tactile switch bracket. Since the top view is good, it kind of show the profile of this tactile switch bracket. Alright, about this, I will not do section view since this is a simple plate, but it have kind of a profile like this on the top view, so I just remade it as a orthographic view. Right here, the front views, I got to, by the way, to make it like this, tangent edge remove. Okay, this one also tangent edge remove for the ISO view, and also for the top view, tangent edge remove. Okay, since this is a typical orthography, it's not a section view. If I have to on the hidden line. Same goes for the top view. Need to on the hidden line. So it means that I have the hidden. Actually, I have a cut through holes. It's a hidden line. Okay, now I will do dimension for this tactile switch bracket. Okay, under notation for smart dimension, the first thing is about the total length. Okay, it's 19. Then the total width is 6, and about the front view, I can go for the diameter of this hole. And okay, before I put the location of this hole, it's kind of like the center marks here. If I don't use the document default, if I go for 1, if I go for, since it is a small hole, if I go for 0.5, so the mark is like that. If I uncheck the extended line, so we only have the point here. For small hole, we don't have a kind like the longer version of the center line, so I just need a tick only. If I go for the mark size of 0.5, it can like have a smaller hole. Okay, if I go for, I think I will stick to the 0.25. Okay, same goes for this one. 0.25, I just need a tick only, and I uncheck the extended line. And this one also. Okay, I just have a tick at that 4 holes, right? So I have the diameter 1, and okay, now for the top view, I can do the detail dimension. Okay, the first thing is about the thickness, 0.5. All the distance from, okay, before I go for further detailing the dimension for the top view here, it's about the position of this hole. I need to position from this line to the center marks. So we have 1 there. Dimension from this line to this center marks. So we have 1 and 1. Okay, let me do adjustment here. 1, 1, 1. Okay, what is diameter? I can go here. I don't want the leader cross the dimension line or extension line of this one dimension. Right. Okay, maybe I delete it. I can go at this for this circle, right? Okay, I think for the front view is enough for the dimensions. For the top view, I need to put the dimension of this step here. Okay, first is this line 2.5, and second is this line here 6.89, and another one is this line 6.5, and another one is the this one 2.5. Okay, since I have the total length of 19, so it's kind of like already know the the balance here, right? So about this arrow head here, this kind we have a double arrow, right? So I can go like this. Okay, 2.5, put it above here. Right. Another thing is about, since I've already given the dimension of the length of the step, it's about the thickness. About the thickness from this line to this line is 1.5 there. All right. Another thing is about the thickness from this. Since I've already given, this is 0.5, so I know already the balance here. Maybe I can go for here and here to give the thickness. Okay, sometimes it's allow for clarity, I can put it like this, right? All right, about this height of this line is already known by is 1.5. It is 1.5 and the thickness is 0.5. So it means we will know the balance here, and also given the 0.5 from here to here. Right, I think I've completed the dimension for this tactile switch bracket. Right, the next thing to do is about the local node here. I will select this, Control C, and paste it. Okay, about this, for the tactile switch bracket is actually is number 12. All right, it's number 12. So this one would be 12. Tactile switch bracket, and component is plastic, quantity is 1, and the scale is for 1, because let me check again, the scale of here is, yeah, is for 1, right? The scale is for 1. All right, so this is a detailed drawing of the tactile switch bracket, and for this isometric view, don't have to be show hidden line, is just outlined like this. Okay, let me save my file again. Alright, the next component that I need to show is the last component is the push button. Alright, the last component will be the push button. Before I do detailed drawing of the push button, I just need to mention that I have already adjusted the position of this flexible coupler detail drawing and also the tactile switch bracket detail drawing. But be careful when you move your detail drawing here. Do not do it like this. You select everything like this and you try to move it. So don't do this, because if you do this, you move it, all your dimension will be shifted. To adjust the position, you have to move the viewport like this and put it into the right position, right? Just to remind you. Alright, now I have space here for me to drag the detail drawing of the push button. Alright, under the view palette here. So I need to browse the push button. Alright, for the push button, I have decided I only need the, what we call it, the front view. Bring it here. And also the top view and the isometric view. Then I press escape. Okay, about the main view here, I will go for one. Right? Right. For the ISO view, I just bring it here, and ISO is, I will go for 2:1, and just remove and also this view, right? Okay, for the front view, so I will do front and top view. Okay, for the front view also tangent is removed. Alright, about the top view, I will delete it. I want to make the top view is a section view. Alright, for this front view is not a section view, so I have to show hidden line. Alright, here the center marks here, if I don't use the document default, if I go for, let's say for 0.5, so I have a right scale for that center mark. And to do the section view, I will go for horizontal, click at this, click OK, then just click OK and bring it up. So this will be my top section view. But if you look at the pointing arrow of the section line is upward, I have to go to flip like this. Then I click OK. Okay, let me bring this a little bit above here. Okay, about the label, since I have already JJ, and this one will be K. Right, I have session KK, and about the scale, I would delete it. Right. Okay, now I have the section view. The top view is a section view. Then I will do basic hatching. And also this kind like revolve, I need to show a center line. So I will select these two line and these two line. Then it shows symmetrical. Okay, now I will do dimension for this push button. Okay, if you look closer here, this is the isometric view. Actually, I have kind of like a chamfer here, a chamfer, and that's why I have a double line chamfer. Alright, the first thing to do is about the diameter here, 10, and also whatever I can see in this front view, the outline, for example, this inner diameter here and also this diameter of this protruding cylinder. So that I will show you, since this is solid line, one is here, another one is this one. Okay, I just remain the position of the dimension for a while at that position. Let me click OK first. Okay, let me do adjustment. Okay, this is 10. Okay, for the front view, I kind of like have put 3 dimensions here. Okay, for the top view, since I already put the major diameter 10 here, so the things that I need to show is about the total, about this dimension of this. I have a dome shape here, so the radius is 8.5, and uh, and also the total height. Alright, about the total thickness or total height of this push button, I can go dimension from this line. And here, I cannot point, here I will bring my mouse, it highlight this curve, and I right click at it and select the point, so it detect the point there. So I bring it to this location. I just click OK, and this one is 1 decimal point. Alright, this will be the total height. And another thing is about the thickness here. So I go for smart dimension. From this point to this point, 0.75. And I can go it like this, right? So the thickness is 0.75. Okay, about this diameter from here to here. Okay, from here is kind like is hidden line. I can put the dimension here. From here to here, and the diameter is 38. Okay, I can go like this, right? Let me adjust this again, because I don't want the leader to cross the dimension line. So I put it at this location. Okay, I click OK. Okay, the another dimension that I already, okay, this one, the protruding cylinder already defined 4, and the inner already given, and the dome radius already given the dimension. And about the thickness is 0.75. Okay, I believe that's all the dimension for the push button, right? Maybe if maybe there's certain dimension that I've missed, maybe I will do the updating in my next video, my final video, alright, to make a final check. So I have this section KK here, and let me adjust this front view a little bit like this, and the bottom node, make a copy, Control C and Control V, and okay, the tactile switch bracket, the not the sorry, my mistake, the push button is component number 9. Right, is the push button, plastic 131, and scale is 41. Okay, the scale is 41. Alright. Alright, let me make a final check. Okay, about there is a title block. I have already put the title, steering rod, plastic cap, flexible coupler, tactile switch bracket, and also the push button. Right? And okay, about the material, I don't have to put here. About the drawing number, okay, now I will decide what is the drawing number. Okay, the drawing number, if I go for the assembly drawing, since I have drawing 1 is the bottom casing, 2 is the top casing, 3 is the opening lid. I mean the rest of the component like the flexible coupler will be drawing number 4. The plastic cap also will be drawing number 4. Hold on. This will be drawing number 4. And also the push button will be drawing number 4. And the tactile switch will be drawing number 4. The one that I missed is the tactile switch bracket is drawing number 4, push button drawing number 4. And the one that I missed is steering rod. Is also drawing number 4. Okay, the rest of the component like the DC motor is a standard part, so we don't have material and also the drawing number. Okay, so I will do the same for the BOM of the exploded view. Right, so okay, I've completed this BOM for this exploded view also, and about the sheet 4 here. Okay, I believe I've completed the detail drawing of the rest of the components. I have 5 components, and make sure your title block is completed. Yeah. Okay, about the sheet 4, I will rename it as just I put it the others, right? I mean the others component. Right, I save my file again. Let me save my file. Alhamdulillah, I've completed the 5 components here. So I believe I kind of like completed the whole set since from the beginning, from my part modeling, then I do assembly exploded and a full set of working drawing. Okay, later in my next video, I will make the final video for the final check and also to show you how I will compile all the works here from part the assembly drawing together with the part modeling and how we will do back and go, and also this set of working drawing, how we compile it to make a full set of working drawing in PDF format. Alright, thanks for watching this video, but before that, please do not forget to click subscribe and like my channel. Assalamualaikum warahmatullahi.